Hi guys, welcome to my channel, and in this video we are going to discuss 4-stage traffic light controller. So guys, for the full video, all of you stay tuned.
karanjetlilive.
So guys, what is a 4-stage traffic light controller? So 4-stage traffic light controller is a circuit which can control the access to 4 different roads by turning light green and red. Okay, now suppose this is my roundabout, and I have 4 roads. So one road goes to Muscat, one goes to Wadi Hibi, or we call it as Hibi, one goes to Leva, and one comes to Sohar. Okay, so a traffic light controller will control so which light will be green and which light will be red. So guys, to make a traffic light controller, we have to pass through different stages. The stage 1 to make a traffic light controller or any sequential circuit is the state diagram. So let 4 different states donate 4 different roads. For example, let Muscat be S0, let Wadi Hibi be S1, let Leva be S2, and let Sohar be S3. Okay, so the first thing what we have to draw is the state diagram. Okay, so total how many states are there? 4. So what is S0? Then when the time is complete, so then the state changes from S0 to S1. Means at S0 Muscat light was green, and S1 Wadi Hibi light will be green. Okay, so again when the time passes, the state changes from S1 to S2. So what happens at S2? Leva becomes green and so on. Okay, so what is this? This is a state diagram. Okay, S0 represents Muscat, S1 represents Hibi, S2 represents Leva, and S3 it will represents Sohar. First stage, state diagram. So guys, then from state diagram, the second stage. What is second stage? Second stage is we make the state table. So what is a state table? What is a state table? It shows what is the present state and what is the next state. So it will have present state, then it will have next state. Okay, if present state is S0, then what is the next state? S1. If present state is S1, then what is the next state? S2. If present state is S2, then what is the next state? S3. If present state is S3, then what is the next state? Again it will be S0. So what do we call it? We call it as a state table. So we make a state diagram. From state diagram we make a state table. So guys, then third stage. What is third stage? We make a truth table from the state table. We make a truth table from a state table. So how do we do that? So I will close this. I will delete it. So now present state is S0. So okay, total how many states are there? 4 states. To represent 4 different numbers, how many Boolean variables we need? We need 2 Boolean variables. We call it as present state variables. Okay, we represent for them. For example, we represent them with X and Y. We represent them with X and Y. And similarly, we have next state variables. Okay, we have next state variables. We will represent with P and Q. We will represent with P and Q. And what is the present output? So when the state is S0, which light is green? And when the state is S1, which light is green, and so on. Okay, so S0, okay, it is 0. So how do we write 0 in binary? 0, 0. S1, how do we write 1 in binary? 0, 1. S2, 1, 0. S3, 1, 1. So these are the variable values for the present state. So what are this? 1, 2, 3 and so on. So S1, S2, S3 and state 0. So S1, how we will write it? We will write it as 0, 1. S2, 1, 0. S3, 1, 1. S0, 0, 0. So this is the value of x and y for the present state, and this is the value of P and Q for the next states. Okay. Now, when the state is S0, you can refer to the first part of the video. Which light was green? Muscat was green. Which light was green? Muscat was green. When the state was S1, which light was green? Hebe. When state was S2, which light was green? Liva. And when state was S3, which light was green? Sohar. Okay. Now, what is a traffic light controller or what is a sequential circuit? Traffic light controller will generate two outputs. Okay. It will take these as an inputs and it will generate next state and it will generate the present light which is green. So these are the next states and these are the present lights which are green. So now from this truth table, the third part. From this truth table, the third part, we will write the Boolean expressions. Okay. So what will be the Boolean expression for P? So take all the values of P which are 1. P is 1 here, P is 1 here and OR them together. So what is this? This is x complement and y. And what is this? Plus xy complement. Plus xy complement. So what is P? X complement y plus xy complement. Okay, if you will look at this Boolean expression. Okay, x complement y plus xy complement is what? It is an XOR expression. So what is P? P can be simply x. P can be written as simply x XOR y. X XOR y. Now let us write the Boolean expression for Q. Let us write the Boolean expression for Q. So what is this? This is 1. What is this? X complement and y complement. And this is also 1. This is also 1. So what is this? This is plus x y complement. Plus xy complement. I can simplify this also. I take y as a common. So I get y complement. In the bracket I have x complement plus x. So what is x complement plus x? According to the laws of Boolean expression, it is 1. Okay. So 1 y complement and 1 is what? Is y. Is y complement. Anything and with 1 will be the same thing. So what will be Q? Q after simplification will become y complement and P will become x XOR y. Okay. Now guys, other than this, I also need the Boolean expression for Muscat, Hebe, Liva and Sohar. So what is Muscat? Muscat is 0. So what is this for 0? S complement, x complement and y complement. Okay, so I will write it here. What is Muscat? X complement and y complement. So what is Hebe? What is Hebe? Hebe is x complement and y. So what is Liva? Liva will be xy complement. And what will be Sohar? Sohar will be x and y. Sohar will be x and y. So guys, now we have the Boolean expressions for P and Q, which is our next state. Next state will be stored in something called as flip-flop, and when the time is complete, it will become the present state. So P and Q, the next state after some time will become present. So P and Q will become x and y after some time. Okay, so let me write the Boolean expressions clearly, and then we are going to implement this circuit in logism. So guys, now here are my Boolean expressions for P, that is X XOR Y, and then I have for Q, that is Y complement, then I have for mustard X complement and Y complement, then I have it for Hebe X complement Y, then Liva, that is XY complement, then comes Sohar, that is X and Y. So here also I made that table again, the state diagram again for your reference. So this is mustard, this is Hebe, this is Liva, and this is Sohar. So guys, now we are going to implement this truth table, this Boolean expressions in logism using D-type flip-flops. So why we need D-type flip-flops? For that I have another video in which I have explained that thing in detail, and I will leave the link to that video in the description section. So guys, now let us implement the Boolean equations which we got from the first part of the video into logism. So guys, here I have written the Boolean equations for P, that was X XOR Y, then for Q, which was Y complement, then for muscat X complement Y complement, Hebe X complement and Y, Liva was XY complement, and Sohar was X and Y. Okay, so guys, now we need to store the value of P and Q, okay, which after some time, which is the next state, after some time, which is going to become the present, which is going to become the present. Okay, so now let us do it. Okay, so for that I need D type flip-flops. For that I go to the memory, and here is the D flip-flop. One I need for P and one I need for Q, and one I need for Q. So let us give the inputs to them. So this is going to be P and this is going to be Q. So let me write here, this is P and this is Q. So let us take the output. So this will be Q and this will be Q complement. This also will be output and it will be the complement. So P will become X and Q will become Y. So what is this? This is X, and what is this? This is X complement. So you know, always flip-flop will generate two outputs. One will be the variable and other will be the complement of that. So what is this? This is going to be Y, and what is this? This is going to be Y complement. So now we have P and Q. So what was P? P was X XOR Y. So here I have X and here I have Y. So what I do them? I XOR them. So here are my gates and here is my XOR gate. So just quickly I'll change the direction, number of inputs to 2 and size narrow, and what we get is P. So let us make the connections. Here is X and here is Y. Okay, X XOR Y. Okay, and what is Q? Q is Y complement. So Y complement is already there. So what I do is I connected with the input of the Q. I connected with the input of the Q. Okay, now what I need to do is I need to clock the flip-flops. Okay, so here is the clock and here also is the clock. So what we do is we clock them, and I take the clock from here and I clock it. Now let us try to test. Now if you see, this is 0 0 0 0 0 0 is for first state. Okay, now let us run it. So from 0 0 the state changes to 0 1. From 0 1 it becomes 1 0. From 1 0 it becomes 1 1 and again 0. See, this circuit for the next states it is working. Okay, so now we also need the circuits for making the light green for mustard, hibi, liva, sohar, green. Okay, so then what do? I take the input output and I take the LED. So LED I change the on color to green. Okay, how many I need? I need 4 of them. I need 4 of them. One for mustard, then one for hibi, one for liva and one for sohar. So let us write here. So this one is Muscat and this is my city Sohar. Okay, so their on color is green. So what is Muscat? Muscat is X complement and Y complement. So I take a AND gate, I take a AND gate. So what was Muscat? Muscat is X complement and Y complement. So this is my X complement and this is my Y and this is my Y complement. So what is this? This is Muscat. Okay, so let us try. When the state is 0 0, Muscat becomes green. So what was hibi? Hibi was X complement and Y. So this is Y, already we have it. Okay, so I take a AND gate and we give it to hibi. So guys, this is our hibi. So what was hibi? Hibi was X complement and Y. So this is AND gate and this we already have Y and here is the X complement. Okay, so which I need and I connect it to hibi. So let us test it. 0 0 0 1 is hibi, so it is green. So what is liva? Liva is XY complement. So for that again I need a AND gate, then we take the wiring. Okay, hibi is X complement, liva is XY complement. So this is my X. Okay, this is my X and this is my Y complement and we connect it to liva. So see, now liva is green. And what was sohar? Sohar was X and Y. So again we take a AND gate, then I connect it to sohar. Okay, so this is Y, this also is Y and this is my X. This is my X. So I take a connection, this also is X. Okay, now the circuit is complete. See, sohar, Muscat, hibi, liva, sohar and so on. Okay, so guys, like here now we are going to add the red lights also. So what we do is, again I go to input output, I take LED, I change the on color to red. Okay, so how many red lights I need? I need one for Muscat and I need one for hibi, I need one for liva and I need one for sohar. So when the light is red, when it is not green, so I take a connection from green and I add a inverter to it. So how many inverters we need? We need 4 inverters. 1, then 2, then 3 and 4. Then I connect it with the green light wiring. Okay, now here is Hebe, and okay, so here we go. So now let us run it. One is green, other are red. 1 green, 3 red, 1 green, again 3 red, and so on. And guys, now we will add the yellow light also. So I take another LED, I change the color to yellow. And how many yellow lights I need? I need them between red and green. I need them between red and okay. So guys, the yellow lights I will connect it to what? I will connect it to the clock pulses. I will connect the yellow lights to the clock pulses. Okay, and this is the clock, and simply I connect it to the yellow light. And now we will see. So between the light changes, yellow comes and the light changes. See? And guys, our circuit is complete. So guys, I hope you understand this. So guys, if you like my videos, please subscribe to my channel. I'll be uploading more lectures related to IT and all kind of stuff. And all of you, thanks for watching and stay tuned.